Welcome everybody to problem 2. But before we start, lots of people might already be wondering, why, Karen, did you put a picture of a quadrilateral in here? Aren't we talking about equal triangular areas? Let's read the problem and then you'll understand why. As shown in the picture, the parallelogram ABCD, E is the midpoint of AB. E is the midpoint of AB, so right away I'm starting to mark this. Probably do that with dark blue. AF equals 2CF. So that's another interesting equation we have. And the shaded part, which is triangle AEF, has an area of 10. What is the total area of parallelogram ABCD? So let's first think about how we can use the conclusion we just got in the last video to help us navigate through this problem. So we have the midpoint, right? We marked that, but I'm kind of confused on AF equals 2CF. Well, first, what is AF? Well, AF is just this line segment right here, and CF is this one. And they seem to be on the same line, don't they? Okay, so if we know that AF is equal to 2CF, I'm kind of starting to think that AC is just split into thirds, and AF is 2/3 of AC, and FC is 1/3 of AC. And that's exactly correct. That should be a conclusion that comes to your mind, because in a lot of problems, they're not going to give you a fraction. They might, but they most likely will not. So it's always a good idea to listen to a keyword and then immediately think about what that could mean. Now we're trying to find, so we know, now that we already have our information marked, let's think about the total area of parallelogram ABCD. Well, in this problem, we're talking about triangles. And we see that AC, it's connected from the point A to its opposite point, C. So it means that parallelogram ABCD is split into 2 equal halves that are triangles. So let's just take that triangle and just look at one half of it right now. So let's look at triangle ABC. So let's first think about the relationship it has. Well, we know that E right here is the midpoint. So its width right here would be 1/2 of that of ABC's. And its height would also be 2/3 of that of triangle ABC's. So that relationship would equal 2/6 or 1/3. Okay, so we know that this is our R right here. This is our relationship. Now we think about how we can using the relationship and 10 and what operation with these two numbers we can figure out triangle ABC's area. Well, if 10 is 1/3 of ABC, we just divide them. So we get 30, and it means that triangle ABC's area is 30. Now, a lot of people might think, oh my gosh, I did so much work and this is my final answer. But really, there's one more step. Because this is the area of triangle ABC. But let's go back to the problem. What is the total area of parallelogram ABCD? Okay, so that's not the final answer, but we know that this 30 is in fact 1/2 of the whole parallelogram's area. So we know the relationship that 30 has to the whole area of ABCD. So that's 1/2, that's a relationship. And 30 is what ABC is equal to. So we just divide those and we get 60 as the answer. So 60 is actually our final answer.